Hello, geometry people. We are continuing our study of similarity, and today's topic is going to be triangle proportionality. So what we have in our diagram here is we have a triangle ABC, and then we connect two of those sides with a line segment DE. We do that so that DE is parallel to AB. Remember, that's our sign for parallel. Now, what happens when that is parallel? You end up getting two similar triangles. That's our symbol for similar. The original big triangle ABC is going to be similar to our smaller triangle on the inside, DEC. And as you recall from our very first lesson, is that when you have similar triangles or similar any shape, the sides are in proportion. So what we're going to be given is a problem that looks like this, and then we have to find a missing side. Now, two things. This is a little bit like our previous lesson when we connected midpoints, because when we connected midpoints it was also parallel. Here, however, D and E aren't necessarily midpoints. It's just drawn so that it is parallel, and you get two similar triangles. The second thing, and I believe the key to solving these problems, is drawing the two separate triangles. Once the two separate triangles are drawn, it is easy to see which sides are proportional to which sides. So let's do an example right now. Okay, it says in triangle ABC, so I saw triangle ABC, I drew triangle ABC. It wasn't drawn for us. D is a point on CA. So I'm going to put D anywhere on CA. So there's my D. And E is a point on CB. So I'm going to put E anywhere on CB. But DE is parallel to AB. So we have that situation right there. We have CD is 4, so I'm going to label that side 4. CA is 6, so this whole side is 6. That's one way to do it. And BC, this whole side, another way to indicate the whole side is you can make a line like this, is 9. So all of BC is 9, and we're trying to find CE, so I'm going to put an X on CE. So my first step is to draw the two triangles. So the first triangle is the big triangle, ABC. And then I'm going to draw the little triangle, which is CDE. Now, what do we have? We have CA is 6. This whole side is 6. BC is 9. This whole side is 9. CD is 4. That side is 4. Find CE. That side is X. Now, once it's separated, it's easy to see which matches with which. 6 matches with the 4, so I'm going to say 6 is to 4, as 9 matches with X, as 9 is to X. All right, let's solve this by cross-multiplying. 6X equals 9 times 4 is 36. Divide by 6. X is 6. The key, draw the two separate triangles, label it, and then what you have to do is find out what the proportion is, what sides match with what. 6 is to 4, 9 is to X. Like I said in the previous lesson, there's other proportions that would be correct, and there's also other proportions that would be incorrect. So I'm going to let you try to find which ones work for you best. But that's how I like to do it. Let's take a look at another example. This one is drawn for us already. In the diagram below, AB is perpendicular. Remember, that's our sign for perpendicular to BE. And AC is perpendicular to CD. Perpendicular means forms right angles. And as you can see, it's also labeled with right angles right there. Now, there's no mention of anything being parallel, but if these two lines are perpendicular to the same line segment, they are going to be parallel. Okay? It says AB is 4. I'm going to put a 4 there. AC is 6, so this whole side is 6. AE is 8. And let's find ED. Let's put an X on ED. Now let's draw our two separate triangles. So I'm going to draw the small one first, and this is A, B, E, and this is 4, and this is 8. And that's going to be similar to the big triangle, which is ACD. This side is 6. Now, it doesn't tell us what AD is, but we know this piece is 8 and this piece is X. So together, if I add the 8 and the X, I'm going to get AD. So I can put X plus 8 or 8 plus X. I just like to put the X first. You see how we got that? 8 and X becomes X plus 8 for the whole thing. Now I'm going to set it up. I'm going to say 4 is to 6 as 8 is to X plus 8. 4 matched with the 6, 8 matched with the X plus 8. Let's go ahead and cross multiply. 4 times X plus 8 equals 6 times 8, which is 48. Let's distribute 4x plus 32 equals 48. Let's minus the 32. And we get 4x is equal to 16. And we get x is equal to 4. Now, oops, sorry, I went off the camera. X is equal to 4. We cross multiplied. Distributed to 4 minus the 32. Now, I want to check this one because we ended up finding ED was X, which would make this whole side here, the AD, equal to 12. And let's check. Does 4 go to 6 as 8 goes to 12? Well, how do we check? You can check by cross multiplying. Does 4 times 12 equal 6 times 8? And yes, because 48 does equal 48. All right? Okay, let's do one more example. The examples are all basically similar in that we're going to have a side that's parallel to another side, and we separate our triangles. But what's different each time is what sides are given and all this sort of thing. In the accompanying figure, AB is perpendicular to BE. Okay, there we see that. And AC is perpendicular to CD. Okay, there's my D down there. Sorry, we see that. Okay, AB is 4, BE is 3, CD is 6. Find the length of AC, which would be this whole thing here. And that's going to be my X. So our first step is always the same. This is my E. I left off a couple of letters. AB perpendicular to BE. So we're going to have triangle ABE. This side is 4, this side is 3. And then that's going to be similar to our big triangle ACD. Here we have CD is 6. And AC, which is what we're trying to find, is X. Okay, once you have it drawn like this, it's easy to see what the proportion would be. Like that, maybe not so much. However, it's going to be 4 goes to X, 4 goes to X, as 3 goes to 6. And cross multiplying, 4 times 6 is 24, is equal to 3 times X, divided by 3. 8 is equal to X. Okay? So, triangle proportionality. Draw 2 separate triangles. Label the sides of the 2 separate triangles. Determine what your proportion would be, and then it's cross multiply and solve. Good luck on your assignment.